All right, we are continuing our work on probability. Today we are going to look at something called compound independent events. And as usual, we have some video review for you to watch. Watch it all, watch what you need. Remember, you can pause and replay. Also, if you are watching the 523 video, again, watch it all, watch what you need. And really, the videos are the only way that I can help you to see the math and to hear me talk about the math. So I'm hoping that you're watching some of these and finding them useful. Today we have a story about Chris and her older sister Rachel, and they have a system for determining which one of them washes the dishes each night. Chris has been washing the dishes much more than she feels is her fair share, so she has come up with a new system. She has proposed to Rachel that they get 2 coins, and each day she and Rachel will take a coin and flip their coins at the same time. If the coins match, Chris washes the dishes. If they do not match, Rachel washes the dishes. And again, we have an e-tool for you to experiment or explore with. You can click on your Google Doc and it should take you right to that e-tool or go into your ebook if that is easier for you. Rachel thinks that this is a good idea and that her little sister is very silly. She thinks to herself, since there are 2 ways to match the coins, heads, heads, or tails and tails, and only one non-match, heads, tails, then Chris will still wash the dishes more often. Do you agree with Rachel? Why or why not? Now, some of you might agree with Rachel, and some of you might think about how the coins could be heads, tails, or tails, heads. Kind of like when we talk about turnaround facts. 2 times 3 equals 6 is the same as 3 times 2 equals 6. Or is it? Does it matter if they flip the coins at the same time? That is, does the result of one coin flip depend on the other coin flip? And the answer is no. They have 2 coins, they're each going to do their own flip. What are all the possible outcomes when the girls flip their coins? And we are being asked to organize that. So we could have heads and heads. We could get tails and tails. We could get tails and heads. We could get heads and tails. Now, the next problem, we are going to be looking at our list from part C. Imagine that the coins are a penny and a nickel instead of 2 of the same coin. Does your list include both possibilities of getting a heads on the penny and the tails on the nickel and vice versa? Absolutely, because we could think of one of these as one of the coins as being the penny and one of the coins as being a nickel. The coin doesn't matter because each girl will be flipping her own coin. Is Rachel right? Is letter E, is Rachel right? Does this method give her an advantage or is this a fair game? What is the theoretical probability for each girl's washing the dishes? So we have a bunch of different things here. Is Rachel right? No. The method is fair. And Rachel thought she had figured out something where she would have an optimal situation set up and she would not have to do the chore as often. The method is fair. And each girl, the probability for each girl is 1 out of 2. And let's write that the right way. The probability for each girl washing dishes is 50% or 1 out of 2. And let me put that up here so you can see what I just wrote. The method is fair. The probability for each girl washing dishes is 50% or 1/2. And then we're going to do one more problem together, and that is the situation in this next problem. We are given a short situation, and we are asked to decide if it is dependent or independent. Well, let's take a look. Flipping a heads on a quarter and then flipping another heads. This is independent. Independent. Choosing a jack from a standard deck of cards, not putting it back in the deck, and then choosing a king. This is dependent. Picking a blue marble from a bag of marbles, putting it back, and then picking a blue marble again. This one is independent. And then the last one, rolling a 6 on a number cube 3 times in a row. This is independent. For more information on independent and dependent probabilities, what I would like you to do is go ahead and look in your glossary. You can also Google the information. And it's a pretty interesting thing because probability seems so easy, seems so fun, but then there's some little nuances that come into it as we start studying it a little bit more in depth. All right, I'll check in with you next time.